Hello everyone. I'll be presenting a gaze click alternative to you. So how can we click just using gaze? Just imagine 10 years from now, an eye gaze tracker in every device. Just like webcams many years ago, eye gaze trackers are becoming cheaper and cheaper, and at some point there won't be a good reason not to put them into any consumer device. And there are good use cases also for gaze clicking, basically any situation where you can't or don't want to use your hands. Of course, there's accessibility, that's what it's used for at the moment, but also industrial use cases, medical with gloves or dirty hands, but also many consumers would be interested in that. Just imagine yourself cooking in the kitchen, dirty hands, and you want to look up a recipe on your tablet. But there are two problems that we have to deal with to make that a reality. The problem number one is the limited accuracy of eye gaze tracking. There's a built-in natural limitation by the design of our eyes, which we can't really cross. And how do we click? Our eyes are naturally built for pointing. We're looking at different things all the time, but clicking, that's a whole different story. So now the scope of what I'll be presenting to you is gaze-only clicking, so we don't consider any other input device that would defeat the point. We're looking at clicking on discrete targets, such as buttons and hyperlinks, and clicking on links will be also the running application in the talk. And we're looking also at small targets, so not just the conveniently large buttons, but for example here, in hyperlinks, sometimes you get really small hyperlinks, and they're actually smaller than gaze tracking can be accurate. So we have to do something in addition to just gaze tracking to click those targets. So now let's have a look at related work. Let's have a look at direct click alternatives first, which means alternatives where we have to look at the target, and then while looking at the target, we click it. The simplest and most common alternative here is dwell, which means I look at the target, I simply keep my gaze on the target for a certain time, and then it clicks. And the problem here, as you can see from the example, is that for things like small hyperlinks, that's simply not accurate enough. It's simply impossible to exactly target these small hyperlinks. And then we've got a phenomenon called Moiz touch, which simply means if you click by just looking, you get lots of accidental clicks. So now what can we do about it? Well, there are lots of approaches addressing Moiz touch where we can use different modalities for clicking. So we can, for example, use blinking, eyebrow raising, eye gestures, things like that, and they improve the accuracy of the touch of the click detection. But they can't help us with accuracy. We've still got the accuracy problem, and the main approach to solve that is simply magnifying the targets. And typically, you look at the target, and after a dwell, the target gets bigger, zoomed in or fisheye lens, as you can see here. And when the target is big enough, then you can click it reliably directly using your eyes. Now, there's another category of related works, indirect click alternatives, which means that you don't actually look directly at the target when you're clicking it. And the one that we think is the most promising is called multiple confirm. And what's happening here is, let's say you want to click Japan, this link here. So you first look at the link roughly in the area, doesn't have to be too precise, and after short dwell time, so-called confirm buttons appear in the margin with labels. Note the labels are not on these buttons. So what you can do, you flick your gaze into the margin, you find the right label, Japan, and then you look at the corresponding confirm button, you dwell on that for a short while, between 100 milliseconds and a second, and then a click is triggered. So this is very effective at avoiding Moiz touch. So you get the misclick rate goes down below 4%, but it really adds to the click time because you've got these several steps. So depending on the study and the equipment, between 3 and 7 seconds per click. And the main reason for that is that you've got a visual search component in there. So first you look here, you want to click Japan, and now you have to look here and you have to find where in this list of confirm buttons the confirm button for Japan is. And the main problem here is then that in the existing approaches, these confirm buttons are unstable, meaning you can't really know which of these buttons it will be. You really have to search through this list. And even for the same link, like Japan here, when you move the gaze position, as you know, gaze new confirm buttons are continuously added as the gaze position shifts and removed. It may be that the button for Japan is suddenly at a different place, so you really have to do the search all the time. So this is how the gaze click alternative that we propose comes in. Actigaze, there are two variants, dynamic coloring and static coloring. So I explain dynamic coloring first. So how this works is, so again, you look at your target that you want to click. Let's say you want to click the link Persia, and what happens after a short dwell, the links, the targets around the gaze position are colored. Now, in order to click Persia, you flick your gaze into the margin, and as you can see here, there are again confirm buttons in the margin. This time they are colored, and to click Persia, you flick your gaze onto the gray link here, dwell on it for a short while, and then the click is triggered. And so what makes this special compared to previous work? Well, the confirm buttons are stable. They don't change. These colors will always stay like this all the time. So over time, very quickly, you learn where the colors are, and you can use procedural memory. You can completely eliminate the visual search. And you can also animate the crosshair and the button a little bit to draw the gaze and to make it easier to stay in the button. So now let's have a look at the state machine just to understand the details. So to start with, maybe you've just clicked a link. The confirm buttons are disabled. So usually you will have your gaze still in there just from the last click, so it has to be disabled. And then, as the gaze moves onto the web page, into the user interface, after a short dwell, in our prototype 80 milliseconds, the targets around the gaze get colored. Now, as the gaze moves around, this coloring may change, always around the gaze region. And when you flick your gaze onto a confirm button, stay there for 200 milliseconds, then the click is triggered. So now the second variant simply takes the approach, why not leave the colors on? It can be a bit distracting if you have colors popping up all the time around your gaze. So why not just color all the links right from the start and then basically do the same? Again, you look at the target and then you look at the corresponding confirm button. This also has the advantage that you immediately see which color a link, a target has. So you don't have to dwell and then you see the color and then you confirm, but you immediately see the color. So there's potentially a speed up there. And interestingly, this also very much simplifies the state machine of the approach. So again, when we start, the confirm buttons have to be disabled. We move the gaze into the user interface, and all we really do is just record the gaze trace. Okay, and as soon as we move the gaze onto one of the confirm buttons and dwell there for 200 milliseconds, we just look back. We do what we call a posteriori analysis. We just look at the recorded gaze trace and we ask the question, which target is the most likely, given that the confirm button with that and that color was clicked, was dwelled. So we analyze and we find basically the most likely target. You can achieve exactly the same as with dynamic coloring. Now, the design here is fairly flexible. So if you have seen my demo yesterday, you will have seen this. So here, we actually have two columns of gaze-activated confirm buttons, left and right. So all you really have to do is keep the confirm buttons big enough so that they can be accurately activated with gaze dwell, and keep them in the periphery so that you don't accidentally look at them while working with the main user interface. But apart from that, you can put them left or right, top or bottom, doesn't really matter. Now, you don't even have to put them onto the screen at all. As long as they are within the trackable region, they can be also on the casing of the device. For example, for mobile devices where the screen is small anyway and you don't want to waste it with confirm buttons. And so here, for example, you can balance the number of confirm buttons with the accuracy that you need. So if you've got larger targets, for example, larger icons here, it's easier to disambiguate between them using the gaze position, so you need fewer confirm buttons. Usually the area around the display is also within the tracking region of the gaze tracker. So then you don't even need colors at all. Just imagine you've got a very limited, very slow black and white display like an ebook reader. And just imagine you've got hypertext here with links, and these visual identifiers, as we call them, instead of colors, could simply be numbers or patterns or directions or anything really that is a visual identifier. So just imagine behind every hyperlink you've got a number, and to click the link, you just flick the gaze to the corresponding confirmed number here on the side. And we don't even need an electronic display at all. The same technique can be used for static displays like billboards, for example. So just imagine you've got a billboard like this, you've got a gaze tracker somewhere, yes, and you want to allow people to click different parts of the poster. For example, think of a polling station, which just consists of a billboard, or maybe you want to play some audio tracks when people look at different parts of the poster and then confirm the click here with Actigaze. Now, color assignment. So we somehow need to assign visual identifiers, no matter if they are colors or other abstract things. They have to be easily distinguishable. So for all our colors, we chose the colors from a perceptual color space, and we tried to separate them as much as possible in the perceptual color space. And we also try to keep them not too distracting. So we don't want garish colors that change the appearance of the user interface too much. And in our study, we had several people with red-green color blindness, and they were able to recognize the colors and use it. And another thing that we want to do when assigning the colors to links, deciding which target should have which color, is assign them in a way that minimizes inadvertent clicks. And we do that by maximizing the minimal distance between the same color. So basically, the same color, like here, cyan there, pink here, pink there. You want to keep them apart as much as possible so they, you can't accidentally confuse them. And well, you can do that with a very simple greedy algorithm that we have used, which is efficient and which produces really good results, where you basically just iterate through the links. And for each link, you go through all the colors. You find the minimum distance to the basically to the closest link with the same color, and then you choose the color where the minimum distance is the biggest. And that can be done really quickly. So now, how did we evaluate it? We designed a realistic web browsing clicking task. So you've got Wikipedia pages here, then a countdown is shown, and then one of the links is highlighted. And the user has to click the link as quickly as possible. So we've got a within subjects design, counterbalance, 25 participants. We have some free training clicks, 30 timed clicks for each alternative, and we're comparing the mouse, the two Actigaze alternatives, as well as multiple confirm as a related work. So now this is what we get. This is multiple confirm, so better than the previous study, but still not really fast, between 2 and 3 seconds and a long tail here. And now this really surprised us. Dynamic coloring right there between 1 and 2 seconds per click. So that was really surprising for us, and also the tail is much less pronounced. With static coloring, it was even better, so we are much closer to 1 second, and yes, the mouse is still the winner, but we were really surprised how close we could get to the mouse using that gaze-only click alternative. So here also the accuracy you see is fairly low, coming close to that of the mouse, Now, in conclusion, so we've got a discrete gaze-only click alternative using color-coded confirm buttons, which is fast and accurate. And the main ingredient here is to keep the confirm buttons stable and to cut out visual search. And we've got many applications that we can use it for. Thank you.
Go ahead. Hi, Andreas Bulling, Max Planck Institute for Informatics. Nice work. I was just wondering, you eliminate the search time to some extent, but you still have the travel time from the target to the actual button. So what was the reason to position the buttons at the corner or the edge of the screen and not like maybe surrounding the gaze target?
Yes. So we tried that. We tried some sort of radial menu arrangement. and the users found that very distracting. If the buttons appear close to the gaze position, they basically draw the gaze position away. So your idea was basically to make the buttons appear closer to the gaze, is that right? Yes, but as soon as the buttons appear, that movement actually draws the gaze away onto the buttons, so that can be very distracting if you don't want to click at the moment. So just imagine you just want to read, and suddenly these buttons come up. It's really distracting. So we got very negative feedback about that.
Right, Ro?
Hi, Ro Vertigo, Queen's University. So yeah, no, I appreciate the work, but I always just asked the fundamental question, was why would you click with your eyes anyways?
Sorry?
Why would you want to click with your eyes anyways?
Very good question.
There aren't not that many situations like, do I need to go stand elsewhere?
So why would you want to click with your eyes anyway?
Why would you want to click with your eyes anyways?
Okay.
Unless you're disabled and you can't use your finger or a mouse. And the scenario that you talked about with like ads or something on a bus station, there's no eye tracker that works outside that I'm familiar with. And in many other cases, the eye trackers, like integrating them into tablets, is really not that good an idea either. So what is the use case?
So I believe that at some stage we will have tablets with eye gaze trackers, yes. So of course accessibility is an important use case. You have people, for example, with RSI who don't want to use mouse or keyboard. But I believe there are industrial and consumer use cases. So for example, in a garage or on a construction site, people do want to use tablets, and sometimes that's inside. There are inside scenarios where you can actually use eye gaze tracking. You could even use eye gaze tracking glasses. There's nothing that prevents you from doing that. And or for example, in medical applications, at the operating table, you've got gloves, and you can't really touch any equipment, but you want to quickly look something up. That can be useful. But we do believe that consumers would actually make use of that. Just imagine your hands are dirty or wet and you want to look something up.
Right. I'm just saying that most of the scenarios, other than sort of the accessibility scenario, is in circumstances where eye tracking is right now pretty rough. And this kind of stuff is like, one of the points is that you don't want, you want to use this as a means of disambiguated when you cannot do small targets. So a desktop eye tracker would be where you would do this. You use the desktop eye tracker, right?
So you didn't get the last one?
You use the desktop eye tracker, right?
Yes. So you believe it's unfeasible for the scenarios, yes? It doesn't work well enough, or it didn't quite get you? There's no eye trackers for that. Well, people are working on it. When you look at Tobii, when you look at iTribe, they're putting eye gaze trackers into tablets right now. So I believe it's coming.
We're running a little behind, so let's thank our speaker one more time.